Hey everybody, welcome to section 5 of chapter 2. In section 5 we're going to work a lot with graphing calculators. If you have one, go ahead and pull it out now. If you don't have one, then just pay close attention because you're going to get the chance to use one when you get to class. Alright, we're going to solve x cubed minus x squared minus 5x plus 2 equals 0. We're going to solve it on a graphing calculator. We're going to find all of its zeros. Now, there should be 3 zeros because it's a cubic function. So the first thing we need to do is pull out our graphing calculator. And here's mine. Isn't it pretty? Alright, make sure you turn it on by hitting the on button. To graph this cubic, go to the y equals menu. And we need to graph x, so hit this button right here. And then there's the caret, hit that button. Raise it to the third power. And then finish typing it in. So we should have minus x. And then you can just hit the squared button over here on the left hand side right there. There's the squared button. And then minus 5x. And then plus 2. Okay, and then just hit graph. Now, my window's a little bit off, so I'm going to cheat. I'm going to hit the zoom button, and I want to do a standard window, which is down here, number 6. So hit that one. Much better. Okay, now we're going to calculate the zeros, and method 1 is to use the trace feature right here, trace feature. So, hit this button right here that says trace. Okay, and then this little sunshine, sorry about that, this little sunshine should start flashing at you. And you just kind of trace over, hitting the left arrow to those zeros. So it looks like that zero is around negative 1.9 or negative 2.1. It's somewhere between negative 1.9 and negative 2.1. So it's around negative 2. And then hit the right arrow. That 0 is about at x equal 0.2 or between 0.2 and 0.4. Between 0.2 and 0.4. It's really close to 0.4 though. I'm going to say it's right at about 0.4. And then finally this 0. This is not an exact science obviously. It's between 2.55 and 2.7. I'm going to say it's right around 2.6 or so. 2.6 or so. So, get rid of my video, and let's just jot down what we thought the zeros were. Right about, the first one we thought was negative 2-ish, the other one was about 0.4, and about 2.6. I guess I should have put squiggly, because these are certainly not exact. But that's just a really good ballpark guess of what they would be using the trace feature on the calculator. Now, better than the trace feature is the calculate the zero feature. So I've given you a new function here. It's also a cubic, and we're going to use a different method to calculate the zeros. Instead of just approximating them, we're going to get a lot better idea of what they are using the calc feature of the calculator. Alright, so go ahead and type this into your calculator, and then graph it. Okay, so got it in my calculator. Going to hit graph, and there it is. Isn't it pretty? So it looks like it's got 3 zeros. Now we're going to actually calculate these zeros. Now you can get a kind of a decent idea from looking at the table. Hit second graph or second table, and that gives you kind of a decent idea of where the zeros might occur, depending upon what the sign changes are. But we're going to actually calculate. So hit second, and then trace or calc there. Okay, now this is how it works. You have to move, your calculator says when you start moving, wait a minute, it didn't work. Second, calc. There we go, okay. And we want to calculate number 2, right there, a 0, number 2. So hit that, number 2. Alright, your calculator says left bound. So what that means is you take your little sunshine, hit the left arrow, and move to the left of the 0 that we're interested in, and hit enter. Then it says right bound. So move it to the right with the right arrow, and hit enter. And then hit enter again. And boom, it calculated that 0 for us at about negative 1.88 or so. Okay? Do the same thing again. Hit second, calc, calculate a 0, which is number 2. And this time let's do the 0 in the middle. So left of it this time would be above it. Right of it would be below it. Hit enter. And then when it says guess, just hit enter again. And boom, there's that 0. It's right about 0.35. 0.35 between 0 and 1. And let's do the last one. Hit second, calc, number 2, enter. And then make sure to the left of that 0, so hit enter. And then to the right of it. Hit enter one last time. And boom, that one's at about 1.53. So that's a much more accurate way to calculate zeros. It's still an approximation though, so I'm going to put x is about 0.35, 1.53, and negative 1.88. I believe that's what the 3 of them were, right around there. I rounded to the nearest hundredth. Now factoring is obviously a better way to do this if it will factor. The problem is a lot of times these problems don't factor. And so you have to come up with alternative methods to solving them. Okay, so what I've provided you with here is a set of data, a set of several ordered pairs here, up here, and I want you to find out from this set of data, where do the zeros occur? Where does it cross the x-axis? Well, here's a clue. Look for changes in the sign of y, or in f of x. Look for when y goes from positive to negative, because that means right there is where it crossed the x-axis. Positive to negative it crosses, or negative to positive it crosses. So, boom, look right here. That's where it goes from positive to negative. That means somewhere between negative 5 and negative 4, there's a 0. Again, here to here, it goes from negative to positive. That means somewhere between negative 3 and negative 2, it crosses the x-axis. Here to here, positive to negative. That means somewhere between 1 and 2, there's a 0. Here to here, negative to positive. That means somewhere between here, there's a 0. So it looks like there are 4 zeros. Let's sketch the graph to kind of get an idea what it looks like. So, here are your x's, and here are your y's. Negative 6, 5, right about here. This is going to take a little while. Negative 5, positive 2. Negative 4, negative 1. So, and we said that there would be a 0 between negative 5 and negative 4. We're so smart. Negative 3, negative 1. So that means it must kind of go down and start coming back up. Negative 2, positive 2. It crosses, doesn't it? It crosses. Negative 1, positive 4. Sweet. 0, 6. So it goes all the way up and turns around. 1, 5. That's how I know it turns around. 1, 5. 2, negative 3. So it shoots almost straight down. And it crosses between 1 and 2. And then it turns back around and goes, wait a minute, 3, negative 3. So it kind of it starts to turn around. And then positive 4, positive 3. So it crosses. So it looks like we got a quartic function with 4 zeros. Now, can we do our best to approximate what they are? Can we do our best to approximate what they are? Now this is a little difficult. So I want to approximate this point, this point, this point, and this point. So x is about, well, let's see here. The point here was negative 5, 2, and here's negative 4, negative 1. So it's closer to the x-axis when it's at negative 4, negative 1. So I'm going to say that that point is right about negative 4.4, somewhere around there. That's the one between negative 5 and negative 4. Now let's go between negative 3 and negative 2. So it's closer to the x-axis when we're at negative 3, negative 1 instead of negative 2, 2. Down 1 is a closer distance than up 2. So I'm going to say that that point is about, it's a little bit closer to negative little bit closer. It's a little bit closer to -3 than it is -2. So I'm going to say it's about -2.6 or so. Somewhere right around there. Again, you might disagree. Just go with what you think it's closest to. Okay, the next one, between 1 and 2, we have 1 +5 and 2 -3. So the point is closer to the x-axis at 2 -3. So this 0 is going to be a little bit closer to 2. But remember, it's between 1 and 2. So it's right about 1, I don't know, maybe 0.7 or 0.8, something like that. And then finally between 3 and 4, that's the last one, 3 -3 and 4 3. Well, -3 and 3 have the same distance up and down from the y-axis, or from the x-axis. So my guess is it's almost halfway between them, which would be about x equals 3.5. Guys, this is not an exact science, alright? You're approximating, but as long as you get pretty close, I'll still give you the credit. So, okay, last thing I want to talk about today, and that's the location principle. Say that 10 times fast before you go to sleep tonight, and you'll be smarter when you wake up in the morning. If P of A and P of B have opposite signs, so positive to negative or negative to positive, then between whatever A is, between x equals some A and between x equals some B, remember, P of A is some y value for some A, and P of B is some y value. Let's draw a picture of what this looks like. So here is x equals some A, and here is x equals some B. Okay? And these go up, and they meet their corresponding y values. Those y, in this case, that y value would be P of B. Alright, and this down here, it has some y value. That y value would be P of A. Right? Well, here, P of B is a positive number. And here, P of A is a negative number. Okay? P of A is a negative number. Well, that means there's at least one real root R of the equation between A and B. And sure enough, between A and B, it's got to cross because one of the y's was positive and the other y was negative. It's got to cross between there at some root R. You can also think of it like this. P of R, if you plug in R, what will you get for y? Well, it's on the x-axis, so that means when you plug in R, you must get 0. And that's all the location principle says. I should have said of this equation P of X. That's all the location principle says, is that if one y is positive and one y is negative, then somewhere between those two y values, there's a 0. There's a real root. And that makes sense, because if one of them was positive and one of them was negative, it has to cross the x-axis between. Otherwise, you wouldn't have a change in signs for the y values. So, location principle. That's a nerdy term to say something really relatively simple. Anyway, well, that's all for technology and roots. Have fun playing with your graphing calculators. Not too much fun. Don't stay up too late. I know it's pretty exciting, but get some sleep. I will see you all later. Have a great night. I'm out.